One important type of vectors that we care about are the unit vectors. What are the unit vectors? Vector v of length 1 is called a unit vector. They're the vectors that have length 1, magnitude 1, whatever you want to say there. So let me write this out. Formula, the length of v, the magnitude of v is equal to 1. This is how we tell that a vector is a unit vector. So just as a very quick example of this, consider the vector that is with components 2/3 and 1/3 and 2/3. Let's call this u here. If I calculate out the length of u, I obtain square root of 2/3 squared plus 1/3 squared plus 2/3 squared. And if I crunch this out, the square of 2/3 is 4/9. The square of 1/3 is 1/9. The square of 2/3 is 4/9. 4/9 plus 1/9 plus 4/9 is equal to 1. Square root of 1 is course 1. So we see here that u, 2/3, 1/3, 2/3, is a unit vector. Couple of important things that we have to do with this is how to find unit vectors. So this is one very, very common trick that we can have. So suppose that we have any vector v. What we can do is that we can turn v into a unit vector in the direction of v. By the way, this little notation here, E sub v, unit vector in the direction of v. This notation is not in the book, but I'm using a notation. I think it's useful notation here. Basically, what you do is you take any vector v and divide by the length. Divide v by its length. So our formula, the E sub v, would be 1 over the length of v times v. And this will work for any, I should say here, zero vector. We don't want to be divided by 0, but other than that, this will work for any non-zero vector. So for as an example here, suppose that v is the vector 2, 1, 2. If we calculate out what is the length of v, the length of v is going to be the square of 2 squared plus 1 squared plus 2 squared. So this ends up as the square root. 4 plus 1 plus 4 is 9, so that's 3. So E sub v is going to be 1/3 times 2, 1, 2, which we can rewrite that by scalar multiplication rules as 2/3, 1/3, and 2/3. And does that look familiar? This is how I came up with u in the first place. I took a vector and then the vector 2, 1, 2 divided by its length. That's how I cooked up this vector that I knew it would be guaranteed to have length equal to 1. It's guaranteed to be a unit vector. Okay, so for any non-zero vector, I can ask you to find a unit vector in that direction. So as an example of this, let's find the unit vector in the direction of the vector from P1 is 1, 0, 1 to P2 is 3, 2, 0. So let's just come up with what is a vector from 1, 0, 1 to 3, 2, 0. So 3 minus 1 is 2, 2 minus 0 is also 2, and then 0 minus 1 is, I need a negative sign there. I will skip the details and just say, once again, it shouldn't be too hard to see that the magnitude, the length here is 3. So E sub v is 1/3 times v. So 2/3, 2/3, negative 1/3. So that's how we can find unit vectors. Now there's a special type of unit vector that we're going to be using this a lot, so much in succeeding sections and chapters here. Special family of unit vectors are called the standard basis vectors. And so there are 3 standard basis vectors, I hat, j hat, and k hat. And written as components, I hat is 1, 0, 0, j hat is 0, 1, 0, k hat is 0, 0, 1. Let me just talk about my notation and terminology here. I always want to be putting little vector symbols over my vectors like v here to make sure we remind us that that's a vector v here. I'm putting these little carets over top of I, j, and k here to indicate that they're vectors, not this symbol. And if you were paying attention, let me bring this back over here. You know, I was doing the same thing here. This is something, I mean, this is a little bit more ambiguous, but in both cases, I'm using that hat to remind us that it's not just a vector, it's a unit vector. This is a little bit ambiguous. If you do this, I think that's fine. I was kind of doing it there as well. But I do think it is good form to put the hats, the little caret hats, on top of the I, j, and k to remind you to remind you that those are vectors. Of course, it's worth me reminding you all that the book has a different way of typesetting it. You know, the book is typesetting a very thick I instead of a skinny, you know, this is a normal letter I. This very thick I would be the textbook's way of representing I hat here, the standard basis vector. Okay, so I've talked a lot about notation. I should say things about what's going on here with the vectors themselves. I hat is a vector with a 1, where the first component is 1, the x component is 1, the other components are 0. J hat, the y component is 1, the other components are 0. K hat, the z component is 1. And so pictorially, let me draw a couple axes here. So if this is x, y, and z axis, so I hat is a unit vector pointing in the positive x direction. Y hat is a unit vector pointing in the positive y, j hat is a unit vector pointing in the positive y direction. K hat is a unit vector pointing in the positive z direction. So these are the 3 standard basis vectors here. And so the reason that we care about these standard basis vectors is that a lot of times we're going to be representing vectors in terms of these standard basis vectors. So previously, you know, we've had, let me just write down a sample vector here, 4 to -7. We'll sometimes write it in this component form, or we might write it in terms of the standard basis. This is also equal to 4i hat plus 2j hat minus 7k hat. So these 2 vectors are equivalent. They're different ways to represent the same vector here. And the textbook definitely has you know, uses a lot of this notation. So you should be comfortable with both forms of the notation here for understanding the textbook and solving problems in the future.